Hey, welcome everyone into the WellsTech Garage for this week's training class. It looks like you guys are all here. The comments are rolling in already, so awesome. It's great to see you guys here. Happy June. It's already June 1st. Crazy, right? Time flies, especially when you have a newborn at home. Here's my little guy. I got him obviously behind the wheel right away, right? I mean, you got to do that. Start him out as a car guy when he's young. So there's just a shot of my little guy for you guys. All right, so today, as many of you already know, we are going to be covering evaporative emissions. We're going to go over the operation, diagnosing the system, testing it, and we're going to get a little bit beyond the leak today because there's a ton of YouTube videos out there and stuff already on leak checking systems. So I want to go a little bit beyond that and do something, hopefully, that maybe you guys don't think to do or don't do every day. And we're going to go start to finish through the EVAP system today, okay? So let's start with the tech question. This is going to be that t-shirt giveaway or hat giveaway question. I believe it was you, Warren, that was asking when this would be coming. Well, here it is. Here's your shot to win either a super awesome WellsTech hat or t-shirt in gray, blue, or black. So answer this correctly and you will be a winner. So a vehicle is brought into the shop after failing emissions. Check engine lights on with a code P0442 EVAP small leak. These following tests were performed. There's a service-based scan tool test done. That test failed. It is failing. It has a leak. Smoke machine was hooked up to the service port under the hood. No smoke was found. And the smoke machine was also used to pressurize the system and then watch the gauge. The gauge is maintaining pressure, so it is not showing a leak with pressure. What is the most likely cause of this problem? Okay, I'm not going to give you guys any A, B, C, or D this time. I want to know what you guys think is the most likely cause. Email your answer to me. My email address was right there with the question. Otherwise, it is in the link below or on the screen there. In the description below the video, you will also find it. You have until the end of today, which is June 1st, 2017. You have till the end of the day to get me that email out with your answer to the question. If you're correct, I'd be happy to send you either a hat or a t-shirt. Also, for those of you guys that watch every month, you'll know that today is the last day of the WellsTech survey. You have until, I believe I'm closing it at 4 o'clock Central Time today. Today will be the last day, so if you haven't already completed our survey, that link is also down below in the description. Fill that out for your chance to win one of these tech shirts with your name on it instead of mine. I'd be happy to send that one out to whoever randomly wins that. I will be announcing the winner during the next class in July. One other thing I want to talk about really quick before I get into EVAP is Automechanica Chicago. It is something that is, personally I've never been, but I've heard it's a great training event for technicians. If you guys haven't already signed up for it, I recommend doing it. I will be there every single day. Going to the training classes, I will be an attendee, not a trainer. So I'm just going to be there soaking up knowledge from other trainers and stuff out in the industry. So again, if you haven't already signed up, do that soon if you'd like to go. And then hopefully we can meet up there and snap some pictures together, okay? All right, let's get into EVAP. What exactly is EVAP, or evaporative emissions? Well, it is a system that is intended to not allow our fuel vapors to escape out in the atmosphere. The EPA decided a long time ago that we can't be allowing these fuel vapors to be vented externally. So we put EVAP systems on our cars. It is also one of the top contributors to our check engine light. On almost every make and model, check engine light complaints, EVAP ranks up there near the top for complaints. And again, the goal of the EVAP system is to prevent those fuel vapors. And honestly, guys, I feel like this system is confused or misunderstood on many of our modern cars. And I'm hoping by the end of today, you guys will have a better grasp, a better understanding, because EVAP really should be a moneymaker for your shop. Yeah, I'll just leave it at that. Also, you got to think, if there are almost 1 billion cars on the road today, imagine what it would be like if we didn't have any emissions controls, because these vapors that could possibly vent out in our atmosphere are creators of smog, pollution, and just all around a bad time for planet Earth. So we like EVAP systems, we want them on our cars, and we want them functioning. All right, so the EVAP system. Now, just like every other system on a car, there's really no mandate on what components you use to do the job. The job is to create something to trap those vapors and then some way to get rid of the vapors. Now, every manufacturer seems to do it a little bit differently. Today, we're going to go over this standard EVAP purge seal system, the system that's been around for basically since the beginning of EVAP. Okay, we're going to go over this system. In the next couple months, we're going to get into the split seal system that's used on Asian vehicles. We're going to get into the Chrysler, NVLD, or ESIM systems. We're going to talk leak detection pumps, vacuum pump systems, and the DMTL systems that you see on some Asian vehicles. So over the next few months, we will be getting into these. But today, again, we're just going to be talking the standard purge seal system, okay? So what exactly does that mean? Again, basically, it's been around forever. And it's got quite a few components here, but we all pretty much have been used to dealing with those for a long time. So we got our fuel tank, our fuel filler neck, and then some sort of sealed gas cap, or more so on modern vehicles, some sort of filler pipe door. And I'm talking Ford on this with that capless system. This vehicle that's sitting here behind me is a 2010 Escape. You can see this is what that capless system is. It's the easy fuel system. There's no cap on this system whatsoever. This little door right here, this is essentially our gas cap, okay? There's a seal inside of here. This is sealing our system, okay? Because our system is not able to vent to the atmosphere, okay? And then we have a purge valve or purge solenoid, something like this. It's going to be connected to intake manifold vacuum on one side, and then back through some hoses back to the canister on the other side. This should be normally closed. It's typically going to be mounted under the hood somewhere, with either a hose or, like this one, directly connected to the manifold. I was in a training class one time where this was referred to as the front door of the system. And I like that analogy because we have a front door, we have a back door, and everything in between should be sealed up. So the back door on the system would be the vent solenoid. This would be like a remote mounted vent solenoid. You would find this with a hose attached to it, connected somewhere back to the canister. This is going to hang out maybe in a fender well, maybe up above the transfer case on a Chevy truck. Location on this is usually under the vehicle, somewhere near the canister. Now, this is also a vent solenoid. I'll bring it up so you guys can see a little closer. This is also a vent solenoid. This is the solenoid that is on the Escape that's sitting right here. This is a 2010 Escape, and this vent solenoid mounts directly into the side of the canister. So it's kind of a unique setup. I got pictures of that as well. So here's the canister on the Escape. It's got a nice little shield covering it. It sits just forward of the gas tank. And I took the bolts down. You can see we got some wire running here. This goes to a connector right here, which runs the wire over to our vent solenoid, which is on the other side right here. And then we also have some hoses connecting this thing to the gas tank and the filler neck. As I take it off and throw it on the bench, you can see here's that connector I talked about running the wiring around and to the vent solenoid right here. From here, here's a close-up shot of the vent. And you can see that thing is embedded into the canister. This vent is probably like, maybe 2 inches long or so. And that goes into the canister. Now, of course, you're not able to pull the vent off with this black plastic shield around here. You would have to remove the canister from its let's go back here. You would have to remove the canister from this black plastic shielding. There's just some bolts holding it on the bottom in order to get the vent solenoid out. But that is where it goes, right on the canister. So it's kind of a unique vent design on this vehicle. So just wanted to bring that up because we're going to be playing around with that in a little bit. All right, so we have a vent solenoid going to be normally open. Our vents basically is exactly what it sounds like. It is a vent for the system, which is connected to our vapor canister. This guy here has activated charcoal inside. The goal of this is to store fuel vapors. The activated charcoal kind of absorbs those vapors and holds onto them until the engine is ready to burn them off, until the purge solenoid is open and the engine's ready to burn them. So our canister is holding these vapors. Our vent solenoid is connected to it somewhere through a hose or directly in the side. The charcoal in here is able to kind of filter those vapors out and only allow fresh air to breathe in and out of this vent. Therefore, we're not actually allowing any fuel vapors out in the atmosphere, but our system is able to breathe efficiently, because if it couldn't, how do you fill it with fuel, right? You can't have a fuel tank full of fuel and air and try and force more fuel in there without having the air able to go somewhere, right? Or the fuel vapors able to go somewhere. So that is why we have a vented system. But it's important to note that because we have a vented system, it doesn't mean we're venting fuel vapors. We don't have a vented gas cap or anything like that. We're venting only fresh air, okay? From there, we have a fuel tank pressure sensor. This is the brains behind the operation. This is monitoring the pressure inside of the tank, inside of the lines, inside of the system for leaks, I guess. This is what we're using to check for leaks and check for system integrity. The computer watches the pressure on this, which operates very similar to a MAP sensor, 3-wire sensor, and it's going to watch this over time to check for leaks. I'm going to get into leaks in a little bit here. Some vehicles, like on our test vehicle that was for the question, we have a test port that's mounted under the hood. It's got that little green cap, Schrader valve inside, similar to like on your fuel line. That one is for EVAP. It's typically going to be mounted on the purge solenoid line. You would see a green cap on there, and that is where that's going to be mounted. And then, of course, we have hoses and lines connecting all of this together. So I actually have a setup over here that I put together as a demonstration for you guys so you guys can kind of see it off of the vehicle. Because if we look at it on the vehicle here, it's kind of, 10 plus feet of hose in between, components under the hood, components under the vehicle, near the fuel tank. It's kind of hard to explain how the system functions without being able to see it. Again, you guys know I'm a very visual person, so I built this so that hopefully I would be able to help you guys to understand exactly how the system works. So with that being said, here's our fuel tank with fuel in it and some friends that apparently don't stand upright. Our rubber duckies are drowning in there. But there's our fuel tank. We got a fuel pump assembly in here. These are all GM parts. This is actually the setup of a early 2000s Chevy Cavalier. If you guys are familiar with working on those, that's where all of these parts came from. Failer neck gas cap sealed up. Purge solenoid, which is connected to a hose. Remember, this is going to be under the hood, connected to a hose back to our canister. And then we have another hose coming off the canister. This is the one that's going back to our fuel tank. This is the one when the vapors build up inside of the tank, they'll travel up to the canister. And then we also have our vent solenoid here, which is going to allow the system to breathe that fresh air. So I also have a smoke machine hooked up here, and I'm going to go ahead and power this thing up, maybe. Cycle my power source here. And I should be able to show you guys. I'm going to apply smoke to this so that this is going to be just like vapors on the system, okay? So we're going to start to see our vapors building up in the tank, right? So you guys can see that, yeah? All right, our vapors are filling up inside the tank. Now ignore that this is a smoke machine. Just pretend that these are vapors inside of here. They're going to build up in here all the time. Those vapors have to have somewhere to go. Obviously, we can't just allow them to come out of our gas cap. The EPA says that's bad. So we have to seal up our gas cap. So the vapors are going to travel up through this big hose back to our canister, where our canister's job is, again, to filter with that activated charcoal and store those vapors until our purge solenoid is open and the engine's able to burn. Now right now our vent solenoid is open, and you can kind of see, if I hold it over by the black, you can see that it is able to, there is smoke coming out of it, okay? Now the reason why there's smoke coming out of it is because the charcoal inside of here is not actually absorbing the molecules of the smoke. Because how good would a smoke test do on an engine or on a vehicle if the charcoal canister absorbed all your smoke before it would even get up to the purge solenoid or something like that? So our vent solenoid is going to show the smoke coming out of it. It is venting it, but again, this would not be fuel vapors. This would just be fresh air. So I'm going to go ahead, I'm going to close up that vent solenoid. And as many of you know, testing vents, you get that click sound. So there we go. That's closed up. And remember, our purge solenoid is going to be normally closed. So right now the system is going to pressurize, and we're going to build up a bunch of pressure in here because I have the vent closed. You can see our needle here is dropping, our ball end here is dropping. And what I'm going to actually do now is I'm going to open the purge just like the engine were to be purging vapors out of this thing, okay? So we open the purge. I don't know if you guys could hear that pressure release. or can see this. There we go, you can see that. So now this would be just like the engine drawing vacuum on the system, drawing the vapors out of our tank, out of our canister, and into the engine to be burned. Okay? All right, we'll go ahead and shut this off. I'm going to go ahead and pop this off so we can kind of evacuate out the tank, and I'm going to head back over this way. So basically that is the most basic and standard of EVAP systems functioning. I also have some operation animations for you guys here. I'm going to go ahead and play this. This is only a couple seconds, but basically it's going to operate just like I said. So we have this animation loading. We have our fuel tank down here, fuel tank pressure sensors in there monitoring the pressure or vacuum in our tank. Those vapors are building, and they're traveling up this hose into our canister. All right, our canister's job, again, is to filter those vapors because we can't allow those vapors out in the atmosphere, so we're filtering, and they're going to travel up through this hose and through our normally open vent solenoid into the atmosphere. So if we're building pressure in here, we're able to vent that pressure into the atmosphere after it's filtered, and it goes up into the atmosphere, okay? So this is this, I know it says idle mode here. This isn't engine idle. This is like the system in idle. This is the system key off, engine off. This is the system when it's not purging. This is the system when it's not testing. This is the system just kind of hanging out, doing what it's supposed to do. But at some point, that charcoal canister becomes saturated. Those fuel vapors overcome the capacity of the charcoal canister potentially, and they need to go somewhere. We have to get rid of those vapors. That's when we open up that purge solenoid. So then we would have something that looks like this. So again, our vapors are flowing up from the fuel tank into our canister, and at some point the computer decides, okay, it's time to turn on the purge solenoid. Let's clear that canister of fuel vapors. So we're going to open up the purge and allow the engine vacuum here to draw the vapors out of the canister and restore the, or just empty the canister of the vapors. Let me pause this so you guys can see. All right, so we're drawing those vapors. Now, if you guys remember from the last class, I asked that question involving a stuck open purge solenoid causing a rich or a lean condition. Well, it's important to note, look at this animation. Our vent solenoid here is still stuck open, okay? Now the answer to the question was it could cause either rich or lean. So we open up the purge, the computer's going to account for that. It's going to change fuel trims, it's going to watch the action sensors, it's going to account for that. But what if the computer at this point isn't commanding the purge solenoid? What if it's stuck open physically? There's maybe some stuff stuck in there, maybe it's rusty and it's jammed open. Something is causing direct engine vacuum to be applied to our EVAP system at all times. We're going to draw those fuel vapors out anytime the engine is running. So if that canister is now saturated with vapors, we're going to draw those out, engine running. What are we going to have? We're going to have a rich condition in our engine. The computer isn't preparing for this. It didn't open the purge solenoid, so it isn't prepared for it, so we're going to have a rich condition. But what happens when we use up all those stored vapors? What happens when they're all gone? Well, our vent solenoid is open, connected to fresh air. We're going to draw that fresh air right out of our canister into the engine and cause a lean condition. So really, our stuck open purge solenoid can definitely cause rich or lean concerns depending on saturation of the canister, depending on fuel level, and many other things. But the answer was both conditions. I just want to see if there's a bunch of comments on here. All right. You guys are commenting in a bunch. Good. No emissions controls. We used to call that freedom. All right. Well, unfortunately, if there were no emissions controls nowadays, we would all be in a very smog-ridden planet, and that just wouldn't be good. All right, so let's get back to this. All right, let's talk, open this one up. So let's talk some diagnostics now. Now, I'm not going to go to the vehicle quite yet. I want to talk through some of these different options and different things before we get to the vehicle. So common customer EVAP complaints. First and foremost, we're going to see the check engine light on for some sort of EVAP problem, an EVAP-related code. It's less common to have any sort of drivability problem, you know, not like a misfire code, a lean code, a rich code, a transmission code, something like that. Most customers are not going to notice any sort of issues drivability-wise with an EVAP problem. You're not going to have a drivability issue for an EVAP leak. Now, there are some conditions of sticking open purge or vent solenoid, something like that, that could cause drivability concerns. So this unable or hard to refuel the fuel pump keeps clicking off, and that's the nozzle at the station keeps clicking off. Well, like I said, you have to have some way to displace all those vapors and air that's inside the tank when you're filling, otherwise the nozzle's going to keep clicking off. So if you have a vent solenoid that's either stuck closed or plugged up, the filter in here is plugged up, something like that, you're going to be clicking that nozzle and it's going to keep clicking off, keep clicking off, keep clicking off. You're not going to be able to fill the system because there's nowhere for that air or fuel vapors to travel. So that would be a potentially drivability related customer complaint. This hard start, stumble, stall after refueling, this would be something, again, related to the purge solenoid. So you have this thing stuck open. You're building pressure inside of the tank. It needs to go somewhere when you're filling, right? You're dumping fuel into this thing. Pressure has to go somewhere. Well, it's going to go through the canister, out through the vent. But what if your purge solenoid is open at this point? That pressure could force its way, force fuel vapors into the engine, into the intake manifold, and essentially cause an incredibly rich condition as you're refueling. So you start up the vehicle, it's really rich, it starts and dies, doesn't start at all, maybe floods out, that kind of thing could be caused by a stuck open purge solenoid, okay? Fuel smell, obviously any of this stuff has fuel vapors traveling through it. If it's leaking, if it's cracked, if it's damaged, you could end up with a fuel smell. And then, obviously unable to pass emissions. Check engine light on, you're not going to pass emissions. So those are the common complaints. Here are the common codes related to EVAP. These are going to be the OBD2 specific codes, anything from a 442 small leak all the way up to the 457 gas cap loose. Now there are way more codes than this. We would be getting more manufacturer specific on this, so I didn't want to include them because I want this to be generic. These are typically the codes that you will see come up under a generic OBD2 code pull, okay? So you have your small leak, your circuit control codes, a couple fuel tank pressure sensor codes, gross leak, very small leak, and a gas cap loose or check gas cap code, or potentially a check gas cap light. So common failures related to EVAP, as many of you know, leaks are going to be the biggest failure that we see in the shop. Typically, you'll come in with the vehicle will come in with a small leak, large leak code, something like that. And this is commonly because solenoids fail, hoses fail, dry rot over time, clamps fail, that kind of thing. Stuck open or closed vent or purge solenoids, we kind of went over that a little bit already. Fuel contamination in the vapor canister. Only vapor goes in this thing. This only has vapor in it. If you get liquid fuel in it, I recommend replacing. This happens because of something like topping off the fuel tank. If you're one of those people that always wants to try and round up to the next dollar or something like that, if you constantly top off that tank, it's possible to force, on certain systems, raw fuel into the canister. Okay? So don't top off your tank. When that thing clicks, it's done. It's full, unless you have a vent solenoid problem. All right, so fuel contamination in the canister, it's only intended for vapors. Also, Ford, on this specific vehicle right here, has a problem and TSB related to the purge solenoid, where this thing will stick open. And they state that obviously you should check your purge solenoid, see if it's stuck open. If you find that it is stuck open, they suggest that you inspect the canister. Pull the canister down and see if it has raw fuel inside of it. It's possible that this thing could draw enough vacuum on the system that it would actually siphon fuel off the top of the tank and draw it into the canister if it is stuck open, okay? So keep that in mind. Any sort of raw fuel in the canister, it should be replaced. Physical damage, potholes, speed bumps, road debris, that kind of thing. Just like brake lines, fuel lines, anything underneath the vehicle, you could cause damage, cause codes, leaks, that kind of thing. We see this pretty often in the good old state of Wisconsin with potholes. Our roads are in excellent condition, so we see potential problems with that. Manufacturers have gotten pretty good with covering up the EVAP components. Like this one has this shield on it here. Trying to protect it, trying to keep it from getting damaged or a hose getting damaged, anything like that. They have gotten very good at doing this. All right, and then we got wiring and circuit failures. A vent solenoid lives outside of the car. Its wiring lives outside of the car. Potentially could have wiring and circuit failures. And then fuel tank pressure sensor issues. They're definitely more rare. I know in my time as a tech, I've replaced very few fuel tank pressure sensors. I know when we get a lot of calls on the tech line, there's people asking about replacing the fuel tank pressure sensor, but it all comes down to understanding the code, and basically at that point they're reading down a list of potential causes and fuel tank pressure sensor happens to be on there. The sensor's job again is to monitor the pressure inside of the system or vacuum inside of the system. It's possible for it to be skewed or damaged, but it's also possible that something else is causing problems and that fuel tank pressure sensor isn't actually the root cause. All right, so leak testing, how does the system exactly know if it's leaking? So I'm going to get into some of these leak test procedures. I have that set up over there also, but we'll get to that in just a second. First I want to talk about continuous, non-continuous monitors. Continuous, well, most of us know EVAP problems or EVAP, the EVAP monitor in general for emissions is a non-continuous, takes a long time to set, kind of a pain in the rear to set. That is a non-continuous monitor that requires very specific set of parameters to be passed in order to even run this leak test right here. We are going to continuously monitor the circuits and purge solenoid, vent solenoid, fuel tank pressure, and fuel level input. This is vital for vehicles to have a fuel level input, especially newer vehicles where the computer is actually calculating vapor inside of the tank. It needs to know the fuel level as well as the temperature. Okay, here's some parameters for leak testing. Again, these are very vehicle specific. You're going to want to do this research on a per vehicle basis. These parameters that I've pulled up here are for this escape right here. You can see we have intake air temp, 40 to 100 degrees Fahrenheit. Okay, so our intake air temp has to be within that to run the test. We have to have a 6-hour cold soak event. Okay, that's kind of interesting. So the vehicle has to sit for 6 hours in order for this thing to even try to run the test, okay? What's nice is our scan tool manufacturers have caught on to this, and they give us this little button right here. So I'm loaded into the scan tool right now under functional tests, EVAP system cold soak time bypass. It's essentially a click of the button, and the vehicle then thinks it's sat for a 6-hour cold soak. So you can try and get this thing to force run the monitor by applying that button and making it think it's sat for those 6 hours. And then we have, this thing can't have gone through a refueling event. The system is going to check at a key cycle. It's going to look for a 20% increase in fuel level. If it notices more than a 20% increase, it will call that a refueling event, and it will not allow the leak test to run. It will, however, run the refueling event leak check, basically checking if the gas cap is on or not. I'm going to talk about that in just a little bit. The vehicle has to be traveling between 40 and 80 miles per hour with a fuel level between 15 and 85%, and you have to be between 20 and 70% load. So if at any point during the test, during the leak check, if you bypass or go, if any of these parameters are not met, say you slow down, say the vehicle's in the middle of a test and you run into a traffic jam and you go from that 65, 70 mile an hour mark down to 35, you just failed the test, or not failed the test, you didn't complete the test, so you now have to start over. Start at the beginning again every time. It needs to stay in the parameters for the entire test or it will not complete. All right, so now we have the test mode. I'm going to start with it on here and then I'm going to show you guys on there, and then we will do some stuff on the vehicle also. So let's go here. So here is test mode. This is how we're going to be checking for leaks. So right now the engine is purging, the purge solenoid is open, we're drawing fuel vapor out of this thing, our vent solenoid is open right now, we're in purge mode. Now what we're going to do is we're going to enter into test mode. So what does the computer do? It closes our vent solenoid, it shuts the back door. The back door is now closed, so we now have a system that is sealed at the back with a vacuum source at the front. We're going to draw this entire system, all these hoses, the fuel tank, everything, we're going to draw this all into a vacuum that is being monitored by the fuel tank pressure sensor right here. So what the sensor is doing is it's watching pressure or vacuum inside of the tank. So the purge solenoid is duty cycle opened, drawing vacuum, because the engine is hooked up direct engine vacuum, and the sensor's watching for a certain level, a certain vacuum parameter, which is going to be different for each vehicle, but it's looking for a certain target level parameter. Once it reaches that, so let's just say that it's 8 inches of water, which is what this escape is. So we reach 8 inches of water, what do? We shut the purge solenoid off. So now the front door is closed, the back door is closed, and we're checking the entire system for a leak. We're checking from between this hose clamp on the purge solenoid to this hose clamp on the vent solenoid, okay? All of these hoses, the canister, the tank, everything, we're monitoring it for leaks. We're watching our fuel tank pressure sensors, either voltage or pressure reading, and we're looking for that to decay over time. Now again, this is going to be different on every vehicle, but basically we have this threshold. We drop the vacuum below the threshold. So this vehicle, 8 inches of water. So here's our vacuum level. We come down, 8 inches of water. We fall below the threshold. We shut the front door. Okay, front door is closed, back door is closed. The entire system is sealed. We're below our threshold. Now we watch and we wait. And we wait a certain amount of time, depending on fuel level, depending on temperature, depending on the vehicle. We have to wait this certain amount of time to see if that vacuum decay happens. And now we'll always see vacuum decay. I have never personally tested a system that didn't have some sort of decay. Let me know if you guys have. I'd be interested to hear if there's a perfectly sealed system out there. I've never run into one. But we will see some decay. Again, there is a threshold, a set amount of decay that is allowable in a set amount of time. And those are stipulated by the manufacturer to determine if it's a 20,000th leak, a 40,000th leak, or a gross leak. Now I have heard, and I don't know when or what models are going to have it, but I have heard rumor that we're going to start to see a 10,000th leak parameter or potential test on newer vehicles. So if you guys know of anything running and testing for a 10,000th leak, I'd be really interested to know if there is anything out there on the road today or coming up very soon that is testing down to a 10,000th leak. Okay, let's go over here now, and I'm going to kind of show you guys with the voltmeter connected to our fuel tank pressure sensor. I'm going to both apply vacuum and pressure to our tank, and we're going to watch as I turn on the voltmeter. We're going to watch this all happen, okay? I'm going to apply our gas cap back to here. Here's our voltage right now. So I think you guys can read that, yeah, 1.5, we'll call it 1.5 volts at atmospheric pressure, right? Our gas cap is off, there's no pressure, no vacuum inside of our tank. We are currently at atmospheric. We will see this thing sit right about here. Now, this is, again, a GM fuel tank pressure sensor on here. What's unique about GMs is if we pump pressure into this system, if we use this smoke machine and pump pressure into there, we're going to see that voltage go down. If we suck vacuum on the system, we're going to see that voltage go up, which is kind of backwards of thinking, and it's actually backwards of a lot of other vehicle manufacturers. So if you're checking fuel tank pressure on a GM, make sure you realize that pressure will make the voltage go down, vacuum will make the voltage go up. So let's go ahead and do that. I'm going to go ahead and close. Our vent solenoid is closed. I'm going to close our purge solenoid. So now the front door and the back door are closed. And what I'm going to do is I'm going to go ahead and test this system. I'm going to start with vacuum. So I'm going to put a vacuum pump onto our purge solenoid here. And now I need to reopen this valve in order to draw a vacuum on it. So I'm going to open our purge back up. And before my hand cramps up, we should see this thing drawing vacuum. And you can see vacuum is being applied and our voltage is going up. So let's say the threshold in the computer for this vehicle is, let's just call it 4 volts. So I'm going to draw this thing to a 4 volt mark, okay? Right there, we are going to leave it sit there, and I'm going to close up the purge. So I just disconnected the purge is now closed. I'm going to pull the vacuum pump off of here, and our front door and back door are now closed. That's our vacuum decay. Watch it drop. We are losing vacuum on this system. This system is potentially leaking. Now again, I mentioned that there's no such thing, or that I haven't run into, a perfectly sealed system. So do we know if this is acceptable or not? Is this acceptable leakage or not? That's going to come in where you watch the voltage and the time according to the parameter that the code sets for, and then you can determine that, okay? So right now we're sitting at that. Now I'm going to show you guys if we had a leak. I'm going to try and get this cap off and create a slow leak. I'm going to try not to drop all the vacuum in the system. Maybe. There we go. Oh, maybe not. Oh. All right, so we dropped all the vacuum. We're back to atmospheric pressure. I couldn't get it to slow leak, but that would be now back to atmospheric. And now if I pressurize this, it's going to be the same thing. I'm going to have the purge solenoid closed. I actually have a piece on here that's connected to the machine. And I'm just going to go ahead. I'm going to do an air test on this system now. Remember, our back door, our vent solenoid is still closed. We're going to watch our voltage drop now because we're applying pressure. And now what's nice about a smoke machine like this is it's got this little gauge here. I know it's going to be hard for you guys to see the little needle bouncing around in there. But it is labeled 10, 20, 30,000 leak. And after this system stabilizes and pressurizes the entire system, we're down to very low voltage. And our needle is now hovering the 10,000th leak mark. So this system is sealed up to a 10,000th of a leak. So if the machine is calibrated correctly, our system would be passing the computer's test, because on a early 2000s Cavalier, they were only testing at 40 or 20 thousandths of a leak. So that would be a simple leak test on a simple system. Now, there are other ways to do it. I'm going to show you guys using the lab scope, show you guys using the scan tool over on our Escape in just a few minutes. But I'm going to go ahead and I'm going to open up the vent solenoid. Oh, this is good to know. So the system passes the leak test, right? So we're below the threshold for the X amount of time, whatever it ends up being, we're passed, okay? The leak test is passed. But now what it does is it opens the vent solenoid and it watches for our vacuum or our pressure to get back to atmospheric in a certain amount of time. It has to do that quickly in a certain amount of time in order for it to pass the test for a vent solenoid blockage code or something like that, something related to the vent solenoid. So it's going to watch this voltage. As I open the vent solenoid, the computer is going to watch that voltage and it's going to look for it to return to atmospheric very quickly. And again, this will be fuel level dependent and temperature dependent, and the computer will have a set time. So there we go. I just disconnected the vent. And is our vent stuck because I left it plugged in too long? Ooh, she's warm. I think our vent solenoid is stuck. Don't leave your vent solenoid plugged in for 10 minutes. There we go, it just opened. And you can see it return back to atmospheric. So this vent solenoid was turned on this whole time that I was talking, so that is why it probably stuck. And it's also been on this machine for quite a while. So, all right, so that is that vent check. It's going to check for the blockage in that system by watching the bleed up time after the vent is open. All right. Let's go back over here. Got a couple more things I want to cover before we whip out the lab scope and the scan tool and get to the vehicle. I know that's what you guys are waiting for, the fun stuff, right? Let's just say I want to just check out the comments and see if there are anything I'm missing. All right, Eric O is here, Keith is here. Yeah, Eric, you're probably right. The smoke machine pressurized the vent too much and would not allow it to open. So tapping it did open it up. You are probably right on that one. All right. You guys are talkative today again. Awesome. All right, let's get back to the task at hand. So I was talking about thresholds and levels. Here is the one for our Escape. Now, fortunately, we have a Ford in here. I was able to pull that OBD2 theory and operation page up and get this information. So we have 8 inches of water is our spec. And for those of you guys that aren't engineers or don't understand inches of water, because I definitely didn't or don't, that is equivalent to just over a quarter PSI. 2.5 inches of water, which is our bleed up spec, is just under a 1/10 of a PSI. So we're working in very, very low amounts of pressure. That is why you have an EVAP-specific smoke machine. That is why you don't go applying shop air to your evap system. We're working with a very, very small amount of pressure that this system is testing with. So I went through these and I kind of just went over what they were and put them in plain English so I could, so I could understand them. Basically, if you have a gross leak, so P0455 gross leak, I could have stopped bumping the middle button on this mouse. You're going to see that the system is unable to achieve that 8 inches of vacuum over a 30-second evaluation. So basically, the back door vent is closed, the purge solenoid is open, and the computer's watching the fuel tank pressure sensor and trying to achieve that threshold of 8 inches of water, or roughly just over a quarter PSI of vacuum in that system. It was unable to achieve it. It must have a large leak. Now, that same test is done directly after a refuel event. Remember, we were talking refueling events, how the computer watches that 20% fuel level change. It's going to check for that. That is going to be the gross leak cap off, P0457. This will set that check gas cap light. It is looking for, again, unable to achieve that 8 inches of water after 30 seconds after a refueling event, okay? So that is that gross leak. Then if we get into our leak spec, greater than a 2.5 inch of water bleed up over 15 seconds. So if we have a 40,000th leak, a P0442, we've now drawn the system down. Our front door was open, our purge was open, drew the system down to that 8 inches of water, shut the front door, back door was already shut. Now we're going to watch, right? We're going to watch over 15 seconds of time. We're going to look for that 8 inches of water to increase by more than 2.5 inches of water. So if we'll call that threshold then, that would be what? 5.5 inches of water would be our threshold. If we cross that line in 15 seconds or less, we're going to set a P0442 40,000th leak after it fails numerous times in a row. If it holds under that threshold for more than 15 seconds, but less than 30 seconds, then we would be setting that very small leak, that P0456 code, because we still lost that 2.5 inches of water vacuum in there, but it took longer to do, so it must be a smaller leak, right? And then this vapor generation limit stuff, I'm going to get into that in just a little bit. All right, so here is some cool little flow charts that I had found from Ford. This is some interesting stuff. I'm not going to go through them completely, but I'm going to let you guys can do that if you wanted to pause and watch this again. But basically, I'll do the 20,000th. You start, run the test. Are the conditions met, yes or no? If the conditions are met, it checks for a refueling event, yes or no. If it wasn't a refueling event, we're going to go ahead and open the purge and pull down to that target vacuum, that 8 inches of water. And then we're going to check to see if the vehicle was able to obtain that and if it's at idle. If it's at idle, we're going to close the purge and we're going to start to measure over time. We're going to be watching that system over that 30 seconds or 15-second window, whatever it was. And we're going to look for that bleed up for that 20,000th threshold. If we bleed up greater than that threshold, we're going to set a very small leak. That fault management is going to take 2 driving cycles, and then we're going to set this cool little light. I don't know if any of the Ford vehicles I have ever been in have set this style check engine light, but for whatever reason, Ford decided to use this in their flow chart. I think it's kind of cool. Maybe we'll see that on the dash of some of our newer vehicles. But basically, this is just the way the system operates in a cool little flow chart that might be easier for some people to understand. All right, now I want to talk a little bit about EONV, engine off natural vacuum leak checking. This is something that has been around for a while now. California compliant, typically vehicles will have this. I'm going to be talking specifically about this vehicle here. Again, you're going to be wanting to check your service information for the specific vehicle that you're working on. But on Ford, this vehicle, if it was California emissions compliant, would have a standalone, I call it standalone. It is internal of the PCM, but it is a small processor inside of there that doesn't require the PCM to wake up in order for it to be operational. So basically, this allows us to check the EVAP system without waking up the PCM and drawing a ton of current and killing our battery. So the inputs that are monitored by this little, we'll call it this little computer inside of the PCM, is going to monitor our fuel level and our battery voltage. Okay? If it says that both of those are good, it's going to close our canister vent and it is going to check and run a leak test, okay? There's 4 stages of this testing, and again, it's going to monitor our fuel tank pressure over time with the EVAP vent solenoid closed, and it's going to watch for vacuum or pressure thresholds to be accomplished. Okay? So it sounds maybe a little complicated. We need to understand that as fuel sits in your fuel tank, it's constantly creating vapors. Hot fuel is going to create more vapors. Cold fuel will condense, the vapors will condense and will actually draw vacuum. So if you have hot fuel, you're going to increase pressure in the tank, and if your fuel is cooling, as the system cools, you will create vacuum in the tank. So that is where this little graph comes in. I think this is a perfect visual representation of what this system is doing. So we have P0, this is phase 1. This is our stabilization phase. So from start of test to whatever this mark is, maybe 120 seconds in, something like that, we're going to allow the system to stabilize. At this point, that little processor that's inside of the PCM will turn on our vent solenoid. It's going to close our vent. At this point, the front door is closed because the purge solenoid is always closed. We just close the back door. The system is sealed. Now, at this point, the computer is going to watch to pass one of these thresholds. So if the fuel is hot and it's creating a lot of vapor, we're going to create pressure, and we're going to try and pass this positive pass threshold. And if it's cool and it's condensing, we're going to drop and pass this negative pass threshold. If it's unable to achieve either of these, it's going to run to phase 2. If it passes this threshold on either of these after phase 1, the test is complete and it passes. But the computer doesn't, computer doesn't give up after one try. It will go to phase 2, restabilize, and then it'll open up to phase 3. Phase 3, it's going to watch it again, except for a longer amount of time, and as the fuel cools, our vacuum will increase in the tank. We'll see vacuum in the tank. Our fuel tank pressure will drop, our vacuum will increase, and we should cross this threshold after 1,600 seconds of time. If it doesn't cross this, then we have a small leak in the system. So at any point between here and here, if we cross, we're happy, the system's done, passes the test, moves on. If it doesn't, we run the test again at some point. If it fails that one also, then we maybe set a pending code or a trouble code, hard code at that point. Okay. So with all that being said, vehicle comes into your shop with an EVAP concern. Where do you start? Well, you got to drop a plan, right? You got to start with your customer complaint, the check engine light, figure out what's going on with it, and then from there, this is probably the biggest tip that I can give you guys today. Don't go and spin that gas cap tight. Don't touch anything on the system until you've tested it, right? We don't want to potentially create or fix a problem that was in the system without testing, because then you have nothing to stand on if you were to have that car come back. So I never touch the gas cap until I've tested the system for a leak. So you could check your freeze frames and mode 6 data, look at your code set criteria, obviously go into your service information. You want to see why that code is setting. And then from there, it's just your standard diagnostics. Verify the fault is currently present, prove it, repair it, verify that it's actually fixed. My story last time with that BMW, always verify your repairs, and then you get to sleep easy at night knowing that it's properly fixed and you have the data to back it up. Okay? I'm going to take a moment and bump over to the scan tool here. I want to show you guys some mode 6 information that might be helpful to you guys. So I'm in generic functions right now on the scan tool, and I'm going to start with mode 6, and I'm just going to see what we have available to us on this vehicle. I'm going to have to turn the key on if I want to do this. All right, key is now on. And as we load here, we should have some hopefully deciphered information from the scan tool manufacturer on this one. Again, if you watched our mode 6 class, you'll know that all of our information isn't always deciphered nicely for us. Sometimes you got to look up those TIDs, SIDs, and MIDs, but we have information here. So we have a purge flow monitor and an EVAP monitor 40,000th leak. Let's just take a look at that 40,000 leak test. And system monitor ready, yes. Enabled, completed, no. I recently cleared the codes in here. That's probably why we're seeing no's on this. But we did pass the test, value of 0, min and max of some high numbers here. Again, what I'm looking for here is I'm looking for this value to be close to that min or max. Could potentially cause an intermittent problem. If it's hovering right on that edge, right on that line, we're looking for that because that can help pinpoint an intermittent problem. Also, we can get out of mode 6 and we can go, if the vehicle has it, to mode 9, in-use performance tracking, and we can see how many times it's run the test and completed the test. So again, information is not always going to clear out right away. I cleared the codes in this thing yesterday, and there's no way that I've started this engine 4,068 times since I cleared those codes. So here's all of our tests that we're running, all of our monitors we're running. And EVAP at the bottom here, we've completed the conditions 234 times, and we've met the conditions 234 times, and we've completed the test 743. So those numbers are nice and high. This thing's running the test, completing the test like it's supposed to. If you're running into a vehicle that won't pass emissions, you know, the little old lady that drives to the grocery store and church on Sundays has only single digits in there, you might have to go out and drive the vehicle. But this is proof that the test is not even meeting the conditions to run. So if you have single digits in there, you might have to go out and drive the vehicle for the customer because they might not meet those conditions. They might not go above 40 miles an hour. They might not, for whatever reason, any of those conditions might not be met. Intake air temp, 40 to 100 degrees. Is this going to run? Are we going to see that condition run in the middle of winter in Wisconsin? On startup, there's no way that well, last winter we did have some nice days, but generally speaking in the winter you're not going to run an EVAP test because intake air temp is not high enough. Okay, so you can look at in-use performance tracking for that. That is going to be found in mode 9. Not all vehicles are going to have this. It seems to be on newer models. Again, we're working with a 2010 Escape. All right, let's just talk for a second about equipment for EVAP testing. Do you need to have a lab scope? Do you need to have a full function scan tool? Do you need to have all this expensive equipment to get into testing for EVAP? And the answer is no. You can do the entire test with service information, a code reader, a DVOM, and a fused jumper lead. You want a DVOM to monitor your fuel tank pressure, or potentially a cheapy scan tool that you can monitor fuel tank pressure with. You need to monitor that, and then you need to be able to jump the vent closed and the purge solenoid open for a short amount of time, seal up that front door and back door, and watch your fuel tank pressure, right? Watch what happens. You have a vacuum pump in the engine. You have what did I see? I saw a Facebook post in one of the technician groups that I'm a part of, and a guy brought up testing the system using vacuum. And he had this vacuum pump set up, and he had hoses running to the vehicle, and he had a little pressure gauge, and he had a vice grip on there. And I asked in there, why do you use that whole setup? When we have our vacuum pump, we have our vice grip, which would be our purge solenoid, that's our door, cutting off the vacuum. We have a pressure sensor already. You know, what is the point of going through all of that extra work, hooking that all up, when you have it available on the vehicle already for you to use as long as the engine is idling and under vacuum? So he hasn't replied yet, but my only thought would be maybe if you don't trust your fuel tank pressure sensor or something at that point. Now today I'm going to be using the lab scope. I'm going to use the scan tool, and we're going to look at this system as a whole on the lab scope. Vacuum gauge would also be useful if you're checking the purge solenoid for being stuck open. You just throw a gauge on it at idle, and you can see if you are leaking. All right. So I'm not going to go too far into all of this here because I'm going to talk about it as we go through this, but visual inspection when looking at leaks is huge. Look for cracked hoses, deteriorated components, hose clamps, anything like that. Chrysler V6s are super common for those hoses underneath the airbox. We've all seen those before. So visual inspection is key. And then you want to verify if the leak is actually present, either with the service bay test or the manual leak test. Smoke machine, make sure it's an EVAP smoke machine. You don't want to overpressurize the system. And then you're supposed to use pressurized nitrogen. I don't know how many people are actually doing that, but essentially the manufacturers want you to use an inert gas when you're pumping something into the system that's going in with fuel vapors and fuel. You don't want to be pumping oxygen into there because oxygen, fuel, what do you need? You need some sort of ignition source, and you have an event, we'll call it that. So you don't want that to happen, so you're supposed to use pressurized nitrogen, but how many of you guys have a nitrogen tank for EVAP checking? I'm honestly curious to see if there are people that actually have it. And then this CO2 deal with a sniffer, and you apply CO2 to the system. I personally have never used it. I've seen it demoed, and it seemed like a pretty cool little tool. If you guys have ever used it, I'd really be interested to know if it works nice, if it's worth the money, if you like it more than your smoke machine. I've always been one to use the scan tool, smoke machine, and that has gotten me where I need to be. But yeah, let me know if you're using that CO2 and that sniffer for testing for leaks. Purge issues, I'm not going to get into these because we're going to kind of go over them when I work in a car. Vent issues, same deal. Voltage drop or load test these things. You know, again, you don't trust that you have 12 volts there and you're happy. Do a voltage drop or load test it because 12 volts might not be able to flow any current. These things take current to open and close, okay? Don't get beat by that. Fuel tank pressure sensor issues, less common. We don't really see it all that often. Scan tool PID, you'll typically see a voltage reading and some sort of pressure, inches of water, PSI, inches of mercury, something like that. I found this nice little graph here. So on our escape at 4.9 volts fuel tank pressure, we are reading 16.6 inches of water. And just for reference, 15 inches of water is equivalent to about half of a PSI. Remember, your fuel tank pressure sensor is your brains of your operation. If that's not functioning, if you can't trust that, you're going to have to use something else. And also, there are fuel tank pressure sensors out there that are not mounted directly into the tank. They're mounted with a small hose on one of the vapor lines or something. It is possible for that to become blocked or restricted. And then you've got to really be watching your values. So that could be interesting to look for. Okay, lastly, before we get to the vehicle, ORVR, onboard refueling vapor recovery systems. This has been something that's been around for a little bit now, but we're seeing it become a lot more popular. What it is it's basically an add-on to the EVAP system that the standard system could not do, and that was contain the vapors during a refueling event. Refueling was the largest polluter, and this started in the late 90s. Basically, we now have a 1-inch filler neck that when you're pumping fuel down it, there's not enough space. It creates a liquid seal and doesn't allow vapors to travel back up the neck. There's also usually some sort of refueling vent valve on the top that is going to allow the pressure buildup from dumping from dumping fuel into the system. That's going to allow for that pressure to be vented into the canister very quickly. And then we typically will have a check valve or float at the base of the filler neck that will seal off the filler neck to not allow any sort of liquid fuel to travel up that neck. And then we also have a larger, higher capacity charcoal canister. Stage 2 vapor recovery, it's not on the vehicle, but I think it's good for you guys to know. How many of us have seen fuel pump handles that look like this, you know, with the little rubber at the end? That's basically a vacuum at the end. This is hooked up to the fuel pump at the station. And basically they would vacuum any vapors that would come back up from the filler neck while refueling. They would vacuum those and suck those back into the tank to not allow them to get out in the atmosphere. The problem with this is that since our vehicles are now running ORVR systems, those vacuums are just sucking fresh air and whatever is in the air in that day. But they're just sucking fresh air and putting that down into the tank. Now I've heard that those vacuums can actually build enough pressure inside of the tank that it opens a relief valve on those tanks and lets fuel vapors out that way. So in 2012, the EPA determined that onboard vapor recovery systems, onboard refueling vapor recovery systems for gasoline vehicles has been widespread. They basically are saying here in all of this talk here that these stations that have this right here are able to start removing them, and it's going to save these stations $91 million annually. So our vehicles have advanced enough that we don't need to have stage 2 vapor recovery anymore. Our ORVR systems are good enough. All right, EVAP-2, this is going to be our next class. Check out our Tech Connect episode for that on June 30th to find out what that one is going to be about. Let's play with the vehicle now. I know it's already been an hour, guys, but I have some cool stuff I want to show you on the vehicle, and I hope you guys will hang out for it because it looks like everybody's still here. Helium. Ozstar's using helium because he likes his high-pitched voice. Nice. All right. Okay. All right, let's play with the vehicle now. So now, as you guys know, and I've said multiple times before, I like to work smarter, not harder. I'm kind of I don't want to say lazy, but efficient as a technician. And if I were testing a system and I was running into problems, errors, something like that, I don't want to work harder than I have to. Fortunately for our escape right here, this is a 2.5 liter in here. If you guys look, our PCM is nice and easy to access. So at the back of the firewall here, you guys can see, oh, just ignore this. This was a used engine that I put in here. But our PCM is right back here. So instead of having to back probe at the fuel tank pressure sensor, instead of having to back probe at the vent solenoid, instead of having to back probe at the purge solenoid, instead of having to find all that stuff, I printed off a diagram, found my connections at the PCM, and back probed right there. Now, not every vehicle will be this easy. This one just happened to be. So I'm going to go ahead and set up the scope and look at some of this as it operates in the system. So I'm going to start with our fuel tank pressure sensor, and that is going to be on channel A, and that is going to be this guy right here. Hey Fritz, can you turn the key off for me? Thank you. All right, so channel A. All right, let's get back to our scope here. Okay, channel A, I'm going to throw it on, we know our fuel tank pressure sensor is probably a 5 volt, so I'm going to just throw it on 10. I'm going to bring it, our offset scale, I'm going to bring that down, and we'll run this. We'll put 0 there, so we're running 0 to 7, just in case it ends up higher for whatever reason. I don't think it will. And because I get confused, sometimes I'm going to throw a label on this. We'll call channel A fuel tank pressure. There we go. So channel A is now fuel tank pressure. So currently our key is off. We're sitting at 0 volts. So I'm going to go ahead and I'm going to throw on our, let's throw our vent solenoid on next. Vent solenoid is going to be our red channel. And I'll bring up the wiring diagrams in just 1 second here to show you guys what's going on. So our vent solenoid is going to be pin, what is this, pin 20, I believe? Make sure I got it right. Yep, pin 20 of the PCM. Ground our scope on the other lead. And let's turn on channel 2. So I'm going to throw on a 20 volt channel here. What's going on? Where'd we go? Oh, we may be froze. Okay, I'm going to start closing things out and hope we get channel 2 here at some point. Hey, there's channel 2. Okay. Now, Fritz, the key is off, right? Yeah. Okay, interesting, huh? 12 volts on channel 2, 12 volts on our vent solenoid wire. Now, what did we expect here? I suppose it's hard for you guys to know what to expect if I didn't give you a diagram yet. So let's take a look at that as soon as I label this channel. Vent canister. No. Is there a vent solenoid label in here? EVAP vent. We'll just call it EVAP vent. All right. So let's bring up a diagram. All right. So this is our purge solenoid. So when I hook up our purge solenoid, this is what it looks like. Pin 1 is going to go back to the PCM. I'm going to assume that this white and brown wire is probably ground side controlled. That would be my guess. This would be our ground side control, and we're sharing power from pin E right here because we're not going to ground side control all of these components at once, right? So they're probably shared power. Let's look where pin E goes. Pin E goes here to a splice to a fuse that comes from A. So fuse 20 amp fuse is going to power our pin E, which is going to be our input into our purge solenoid. Now I wish I had one of those cool touch screens so I could draw on the screen for you guys, like in New Level Auto's videos. He's been doing that. That's pretty awesome. Okay, so we're there. Now let's look at our pin A comes from here. Comes through here to our PCM power relay. Okay, so our PCM powers on the relay, grounds this side, and sends power through pin A. Fair enough. So our PCM power relay is basically the input power for our purge solenoid. Let's see what our vent solenoid is. Again, pin A, so probably back to that same place. Vent control solenoid. looks like here, ground side controlled, I would guess. This would be ground side controlled. We are currently back probed right here on pin 20, and we are reading 12 volts right here. Kind of odd, but let's look at pin A again. Okay, pin A goes here, PCM power relay. The key is definitely off. We are currently key off. The PCM power relay should be open. All right, that looks good. Let's go back to our scope. We are definitely at 12 volts. Okay, so we're at 12 volts on a circuit that's really not supposed to have 12 volts on it right now, at least according to what I think. So let's pull this relay here. Can you bring up the under hood shot? So maybe this is our, oh, can't see it anyway. Okay. Well, bring the scope back up then. I'm trying to pull the PCM power relay currently. I should have a relay puller, that would make sense. And we're still at 12 volts. Okay, I'm gonna leave this thing sitting out. Fritz, keys off, right? Keys off, PCM power relay is out. And our vent solenoid right now, pin 20 of the PCM, and I'm 100% certain this is pin 20, green and blue, I believe that is. Yep, green and blue. Pin 20 at the PCM has 12 volts currently. Now, this is where things get interesting, okay? So look at our diagram, ground side controlled, power flows in here. I would expect to see if this side is powered up, if pin 1 right now is powered up, I would expect to see 12 volts here because we currently have an open circuit right here. We're supposed to, right? The PCM is supposed to, this is supposed to be open. It would ground side control it. So if we have an open circuit here, we're going to have voltage flow through this entire thing, through our solenoid. So if we were to check pin 1 and pin 2 right now, we would have voltage there. If this is acting the way it is right now, we would have voltage here. If we were to disconnect the connector, then we would lose our voltage on pin 20. But still, if we go back to this, pin A comes from our PCM power relay. This is open right now. I have this relay out. This is sitting upside down in the box, and I am getting power on here. Now, this is where we need to be careful with our service information, okay? So, lucky me, I have access to more than one source of information. Here is a different diagram. So here is our vent solenoid. Pin 1 and pin 2 at the vent solenoid, of course, gray and red, green and blue. So again, I'm back probed on pin 2 at the PCM. They go to this other diagram, so we'll go back to that one. They come through here, So I'm on green and blue at the PCM, pin 20. Okay, so this is where I'm back probed right now. Here's our gray and red. This is our power supply that's supposed to come from our relay. Goes to splice 140. Comes from our relay, right? So if we turn our relay on, we should see power here. But what is this? Fuse 5, 10 amp, hot at all times, feeding down to splice 140, through pin 7, down here, up to our vent solenoid, through pin 1, through the solenoid, because we have an open circuit in our PCM right now, through the solenoid, back through pin 2, back through green and blue, and back to our back probe right now, 12 volts. So our service information has lied to us, or not given us all of the information that we had initially hoped for. This is normal. It is normal for our 12 volts to be here. Now I'm going to tell you why. Our 12 volts is supposed to be here because we need to test this thing. California emissions, right? Engine off, natural vacuum leak detection needs to be able to test this thing. That little processor inside of there, its job is to ground control the vent solenoid, right? Well, you can't ground side control something unless it's powered up, right? So we supply power to our vent solenoid at all times so that this little processor inside of there that takes very little current to run is able to turn on the vent without waking everything up by grounding this and having our vent solenoid turn on. So 12 volts right here on this vehicle is normal for key off, engine off, hot at all times. Now, could this create problems down the road? Could this create parasitic draw problems? Could this create just a numerous amount of problems? Definitely. We have a power supplied circuit at all times going to a component that's underneath the vehicle in the environments, in salt, spray, and everything else that we deal with in Wisconsin. We could have parasitic draw across our vent solenoid connector or anything that would potentially draw enough to kill our battery because we're powering this thing up at all times, okay? So keep that in mind to know exactly what you're looking at and trying to figure out. And again, don't always trust every bit of service information you read. If something doesn't seem right, check another source. Okay? That being said, let's hook up one more channel. I'm going to put our purge solenoid on now. That's going to be on channel C. That is going to be our green channel. Make sure our ground stays connected. And that is going to be here. And now we have that on. And we'll turn that on. We'll go 20 volts on that. And okay, so green is sitting at 0 volts. So I'm going to bump that down so it lines up with our blue. So green and blue are both at 0. So our purge solenoid is not powered up all the time, which makes sense. We don't need to have it powered up all the time because it's not used for that engine off leak detection check. So this is vent solenoid. Why I want this? All right, what am I doing wrong here? Canister purge. It's not giving me a canister vent. Vapor. All right, well then we'll just label this one. And then the one in the middle will be vent. Oh, maybe I could just go like this, add vent. There we go. Now we got vent solenoid on there. Okay. So purge and vent purge and fuel tank pressure are both at 0. Vent is sitting up at 12. You want to go ahead and just turn the key on, Fritz? Yes. Put that PCM relay back in. Good call. Okay. Yep. Go ahead and turn it on. So we saw our voltage bump up for our fuel tank pressure. We're up sitting at, what is that, right around 2.6 volts or so. Our channel B here, our voltage at the purge solenoid is currently at 12, and I would expect to see that because, again, we're not grounding our purge solenoid. So I'm going to go back to this diagram. We're not grounding this right now, so we have an open circuit where we're checking. We're back probed right here. It's open on this side. We're going to have that 12 volts flow all the way through the solenoid to our back probe. Okay, that's normal. Okay, so this all looks good. Our fuel tank pressure is there. Now it's possible that this thing has either generated vapor inside or gone into a slight vacuum. So what I'm going to do is I'm going to start by seeing if this thing will change. I'm going to increase our time here so we get a little bit more time on the screen. Go 200 milliseconds. I'm going to slow this way down because I found when testing that we had a ton of hash when looking at the fuel tank pressure sensor. So I'm slowing this scope way down right now. We're only capturing 15,000 samples currently, but I found that this was the best way to reduce hash on our fuel tank pressure sensor. What I'm going to do now is I'm going to actually bring this up to 500 milliseconds. And so we're at a half a second per division. I'm going to go ahead and take this super special cool tool that's usually mounted right next to that locking lug nut tool that you can never find. It should be somewhere in the vehicle on a Ford. And this tool is to open the fuel filler cap, essentially. This tool fits right in here. And what I'm going to do is I'm going to open the system. Just like when on the other system where I took the cap off, I'm going to open that, or I'm going to have Fritz open that. We're going to watch our fuel tank pressure to see if we generated either any pressure or vacuum inside of the tank. So Fritz, you want to shove that in there and see if we did anything as this thing was sitting? Yeah, go ahead. We'll see if we get any change. No change. And that's because our vent solenoid was open the whole time, right? I wouldn't expect to see any change at this point because our vent solenoid wasn't closed. Now, if the system was going through a test and our vent solenoid was closed and we saw 0 volts here, then I might expect to see a change. But okay, let's go ahead and fire this thing up. You want to take that back out. We'll hide that next to the locking lug nut key. And we'll fire this up and look at how this thing reacts. All right, I'm also going to go in the scan tool here, guys. And Dave, if you want to bring up the scan tool in the lower part of the screen so they can watch both at the same time, I'm going to go in data display. There we go, beautiful. And we're going to look at some emission evap data. And look at that, on the scope, the purge solenoid just kicked in. This thing is purging at idle. And our scan tool should tell us that. So I'm going to go in custom graph, and I'm going to take a bunch of this stuff out. Let's go vent valve, emission sure. We'll go with that soak time. Very small. Let's go. We'll go fuel tank pressure. And we'll go purge cycle, or purge duty cycle. We'll go into graph view. All right, so we are definitely purging right now. We're at a 60–70% duty cycle on purge. Our vent is open. And we should see that somewhere. Vent valve here, 0%, so our vent is open, obviously. Vent valve off, and our purge is currently at 81% duty cycle. So again, this is just a square wave duty cycle in here. Looks good. So what I'm going to do now is I'm going to go ahead and I'm going to play with the scan tool and do some actuation control. So again, I'm going functional tests, and I'm going to go output controls. And let's control this vent solenoid. So I'm going to turn this thing on and off. Now, can you bring the scan tool to full screen for a second, please? Full screen on the scan tool. All right, now I'm going to go ahead and I'm going to grab some data out of here related to our fuel tank pressure, maybe, our fuel tank purge. Deselect all. So Snap-on put together this nice list of data related to, you know, the evap canister vent solenoid. What do you guys think? I don't see anything in here related to the evap vent solenoid. Oh, I see fuel system status. That's about the closest I get. So I don't want anything. So I'm going to push. All right, it's going to force me to grab something. Okay, we'll grab that. Well, thank you to the software for not allowing me to see what I want to see. Basically, I wanted to close the vent with the purge stuck open and watch our fuel tank pressure, right? But with this software version, I am apparently unable to do that. So let's watch now on the scan tool. I'm going to open up or close the vent. I'm going to turn the vent on, which would close it. Sorry, let's watch on the scope, I meant to say. I'm going to turn this on, and I would assume as soon as I click this, it's going to cut our purge solenoid off. Oh, the computer keeps it on. Okay. So look at our fuel tank pressure. We're dropping. We are currently dropping. We're doing what we're supposed to. Again, do we know what the numbers are? Potentially. Oh, we must have dropped low enough that the computer said, okay, I'm going to shut the purge solenoid off. And now at this point, we would watch the bleed up rate. And slowly, we are bleeding up. Now, it's not happening quickly, and I didn't expect it to because this vehicle does not have a leak, but we are bleeding up very slowly. And then if I go ahead and turn our vent off, there we go, I just turned it off, and look at our pressure return, and the computer said, I want to purge right away and turn the purge solenoid right back on. So sometimes you can do this with a scan tool. GM's pretty good with the evap purge seal test, but sometimes you can't, and obviously I can't even view the information I want to view with the scan tool. So we can do this all again with just using the just using a fused jumper lead and the stuff that we have. I could hook up the DVOM. I could put that into the fuel tank pressure circuit and monitor that on the DVOM. I like to see it on the scope because I want to see it over time. It's just nicer looking for me. So what I'm going to do now is I'm going to actually back probe the purge, and I'm also going to back probe the vent And I'm going to short both of these to ground. So I'm going to act as a PCM here. Now watch on our scope as I do this. So you'll see our vent, our red line will go to ground. So our vent is closed. The computer is currently not driving the purge solenoid, so I'm going to drive it. I'm going to turn our purge on 100%. And there we go. Our purge is grounded, our vent is grounded. Look at our fuel tank pressure drop. And then at some point here, after I cross that threshold, whatever it may be, I would let off of here. So we'll bring it down just under 1. That looks good. We're under a volt, and I'm going to leave it sit. So I ungrounded the purge. The purge is now closed. Our front door is closed. Our back door is closed. And now what I'm watching is this. I'm watching our fuel tank pressure over time to stay below our threshold. So if our threshold were 1 and we had to do it for 15 seconds and maintain under 1, if this was, say this was 15 seconds, we've currently, looks like we've crossed the threshold. We're above 1, this would fail the test if that was our threshold. Okay? And then if we pass the test, if the computer says, okay, I'm happy, I'm not leaking, it's going to open up the vent, just like I talked about over there. It's going to open up the vent, and it is going to watch that fuel tank pressure sensor to return. And I'll do that here, and you guys can see pressure should return. There we go. So our vent is now open, our purge solenoid is closed, and well, our purge solenoid just reopened because the computer told it to. And there we go. So that's kind of how you can run the system yourself. You don't need to have a scope. You can go ahead and shut it off, Fritz. You don't have to have a scope to do it. I like using the scope because I like to look at things over time. A DVOM will work just fine too. And then when it comes to circuit checking, testing your vent and purge solenoids, when they're grounded by the computer, this thing kind of reigns supreme, right? Test light, incandescent test light is a small amount of load. It's going to be less load than the solenoid would put on the system, but it's enough that it could maybe weasel out those problems that where you're still getting 12 volts, but you're not getting the current behind it to actually do anything. A test light will help you with that. So always keep a test light with you, I guess, and use a test light when you're checking your circuits, because on most circuits you can use it. Be careful with some computer-controlled circuits. You don't want to be loading some with that small amount. Some can't handle it. So know what you're testing before you get there. And yeah, as you can see, I don't have a power probe anywhere. I don't use them. It's a personal choice. I use something like this. If I want to supply power or ground, I'll use a fuse jumper wire on there, just because it's the way I was taught and the way I do it. You guys probably have or used power probes. More power to you. I've seen other guys wreck things with power probes, so just keep that in mind when circuit checking, okay? Oh man, I think that's probably about it. I guess I could just show you really quick. I'm going to pull the hose off the top of the purge. So I got it in my hand here if we look under the hood. If we bring up that camera. Okay, so we got the hose off the top here, and the purge solenoid sits right down here. I know it's going to be super hard for you guys to see, but it is right there. I'm pointing to it. I don't know if you guys can see it or not. But what I'm going to do now is I'm just going to do a quickie check on this thing. Got a vacuum gauge or a vacuum pump. You could use a gauge, whatever. I just have a pump here that I'm using as a gauge. I'm going to throw the hose over the canister side of the purge, and I'm going to have Fritz fire this thing up. And we should not see any vacuum on this unless the computer is commanding it. Yep, go ahead. So you didn't see the needle move at all, right? That looks good. Now at some point, I would assume the computer would start to command this thing. We'll see if it does. And then we would see if it, there we go. So I'm watching the scope out of the corner of my eye. The computer just turned it on, and there we go. We're applying vacuum. Our needle is moving. We're applying vacuum to the system, purging out those vapors. So that's a real quick, easy check. What I do is I unplug the connector. With the connector unplugged, the computer obviously can't control it. You should not see anything on your gauge move. Your gauge should not move with that connector unplugged. if the purge solenoid is functioning properly. Okay? Perfect. Okay, go ahead and shut her off. I think I talked enough. Holy cow, hour and a half. Okay. I'm just going to take a quick scan through the comments. Oh, new level auto. You're saying pierce it, make sure you have the best connection. I hope that's a sarcastic little image after that. My laptop here is not loading it. I don't like to pierce connections. It creates, unless I have to, it can create problems. I like to back probe. That's what I like to do, or wire in some sort of T connection where I can get into it. Just going through. You guys are talkative today. Now I will go through all of these later. As New Level Auto found out, I do go through every single comment that you guys put in here and get back to you on it. I'm just seeing if we're there. Okay, I'll open it up to you guys. Are there any comments, questions that you want to see right now while I still have everything hooked up to the vehicle? Is there something that I maybe didn't show that you've always been curious of, that you want to see with the scope, with the scan tool, anything like that? Maybe you don't have access to the tools. Is there anything else that you wanted to see before I close this out for the day? Let me know right now. I know we got about a 30-second delay, so I'm going to stand here and read through the comments in case you guys comment in. All right. This is amazing, guys. I love seeing all this talk. All right, it looks like Eric O is doing an escape evap issue. It mops the floor with me and ends with a, well, good thing you didn't give away the ending, because who would watch it if you gave away the ending? All right. Yeah, Baxrock 2, you asked if the vent is only closed when the purge is on. The vent is only closed when the system is testing for leaks. The vent is open when the purge is on, unless it's leak checking. So just like in that little animation that I had, here, I'll bring it back up just so you can see it again, just in case it wasn't clear. In purge mode, so we're in purge mode right now. Our vent solenoid is still open. It's still going to be open because we don't want to draw vacuum on the system right now. We don't want to kill this thing with vacuum right now. But we're going to open up our purge, and it's going to allow us to draw those vapors out. And we are going to get some fresh air most likely with that too. But we'll draw all that out together. So our vent is open when we're purging. The only time the vent is going to close is when we are performing a leak test. Okay? Hope that makes sense. How much pressure for a smoker? Well, if you guys saw, and maybe you didn't see because it was kind of hard to see, but our smoke machine over there has a gauge on it. And that gauge, when I was pressurizing it, was about 12 inches of water, okay? Remember, 15 inches of water came out to be, man, I really should have that memorized. 15 inches of water was like, what, half a PSI, I think it was? Let me get back to it for you guys, because I don't want to say the wrong thing. And I don't have any of these memorized with inches of water to PSI. Yeah, 15 inches of water, half a PSI. So our smoke machine was testing with just under half of a PSI of pressure, okay? So, yeah, 1 PSI max on a good one, right. Yeah, you don't want to be overpressurizing the system. And like you guys saw, and like Eric O commented, when that vent solenoid was actually stuck closed, it was because the system was overpressurized at that point. No time limit on education. I'm sorry, guys, that this one went so long. I'm glad everybody stayed with me. We actually have some guests in here that look like they're probably bored out of their minds right now, but I told them it was going to be about an hour class, and as you can tell, it kind of ran over. So I think that's going to be about it for today. Unless there's anything else. Again, could you bring my email on the screen, Dave? Again, answer the question, send me an email out to that email address. If you haven't done the survey yet, please do. Check us out on all the social media, Facebook, Instagram, LinkedIn, and Twitter. Search for Wells Vehicle Electronics. At the end of today, I will be drawing for the tech shirt giveaway. And then I will be announcing who won it in the July class. I'll be announcing what the July class is about in the next Tech Connect episode, as well as getting to some of these comments and questions that you guys might have asked that I probably missed because there's about 74,000 of them. Okay, I think that is going to be it. So thank you guys for sticking with me. Thank you for being there. I really appreciate it. I hope everybody learned something, and I hope you guys don't turn away EVAP problems now. I hope there is a better understanding, and next time we're going to get into the other systems, okay? So thanks again, and we'll see you next time. Happy wrenching.